Okay, so in 8.3, we learned about solutions and how they are formed, and so how ionic compounds dissolve and molecular compounds dissolve. And now we're going to talk about concentration. So concentration is the quantity of solute per unit volume of solution. And a concentrated solution contains a relatively large quantity of dissolved solute, which is what gets dissolved, per unit volume of solution. Dilute solutions contain relatively low quantity of solute per unit volume. So for example, the sulfuric acid purchased by our school is far too concentrated to be used in most lab investigations. The solution must be carefully diluted by adding small quantities of it to water. It is then ready for use for your labs. A concentrated solution that is to be diluted to a lower concentration prior to actual use is called a stock solution. So when we dilute an acid, we always add acid to water, never the reverse, or it will splash. In university, we learned never spit in acid. And that's how I've always remembered. You always add acid to water and not water to acid. Chemists find it most convenient to express solution concentration in terms of the amount, or moles, of solution per liter of solution. The amount concentration, or C, of a solution is determined by dividing the amount in moles of solute, as the letter N, by the volume in liters of the solution. And that would be capital V. So the formula then would be amount concentration equals the amount of solute in moles divided by the volume of solution in liters. Or C equals N over V. So as we said previously, the unit of amount concentration is moles per liter. The amount is expressed in moles and the volume is expressed in liters. Recall that 1 milliliter equals 10 to the minus 3 liters. Once you're done your calculation, check the number of significant digits in the final answer agrees with the least number of significant digits in the calculation, because we are generally multiplying and dividing. So that is the rule for multiplication and division, least amount of significant digits. So how do we prepare a solution? Many chemical reactions involve aqueous solutions, so being dissolved in water. And a solution of a known concentration is called a standard solution. So we'll use those in the lab. We will make up solutions, so we know we have 1.0 moles per liter of sodium hydroxide or hydrochloric acid or whatever other chemical we decide. And we prepare them in what's called a volumetric flask. If you remember the volumetric flask, it's the one that's shaped like this, has like the long neck, maybe you've seen it, and it has kind of a round bottom, and then it has a little line here. So this little line gives us an exact value, so we will know whatever solution is. Let's say this is a 1 liter flask. It'll be plus or minus 0.1 mils. So that's pretty exact. So to make a solution, we prepare it by first dissolving a known quantity of solute in about a quarter of the volume of a solvent, such as water. So we add some solid into the bottom, we add a little bit of water, and then we continue to add the water until it gets to the top. And this, until the bottom of the solution's meniscus lines up with the calibration mark on the flask. That's the calibration mark right here. So when you make your solution, I'm just going to zoom into that little section a bit. So your neck, the neck of the volumetric flask is like this. Here's our calibration mark, and here's the meniscus. So that's how we know we have exactly the proper volume. Obviously it's not going to go on the outsides like that, but the meniscus is where the water adheres to the side of the flask. I'm just gonna fix that side a bit. Okay. All right. All right, so let's work through an example of how we would do one of these problems. So phosphoric acid, H3PO4, is the active ingredient in many consumer products designed to remove rust. What is the amount concentration of a solution that contains 63 grams of phosphoric acid in 250 milliliters? So we have to write down always our givens and what we need to find. So we have a mass of 63 grams. Our volume is 250 milliliters. We'll put that into liters right away. That's what we need. So divide by 1,000, 0.250 liters. And we want to know our amount concentration. So C equals question mark. So we don't have yet our N. How are we going to get our N? Well, we know our substance is phosphoric acid. So we will need to use the mass and the molar mass to find the number of moles. So I will give you the molar mass of phosphoric acid, which of course you will have to find from your periodic table. And it is 98.00 grams per mole. And the first step is to find N. And N of H3PO4 is equal to mass over molar mass. And so N is equal to 63 grams divided by 98.00 grams per mole. So of course we're going to cancel out grams, which will leave us with moles, which is what we want. Put that into our calculator. Oops, let me grab my calculator. $63, 98, so 0.64. Now, how many digits do we need for this question? Well, the least amount is 63. So we need 3 digits to carry through the question. So 0.643 will be what we will hold for our moles. So we have our moles. So now we can find our concentration. Concentration is equal to N over V, which is equal to 0.643 moles divided by our volume at 0.250 liters. Put that into our calculator. So I'm going to keep my number in the calculator, which is what you should do. Don't round at the very end. And we have 2.57, which we'll round to 2 digits, so 2.6 moles per liter. We don't cancel anything because moles over liter, nothing to cancel. So, and we need the therefore statement. Therefore, the amount concentration of a solution containing 63 grams of phosphoric acid in 250 mils is 2.6 moles per liter. Okay, so that's that. I'm just going to erase this out of there. Okay, question 1. Let's work through another example. So in example 2, we have fructose, C6H12O6. Look familiar? Same formula as glucose, but different structure. So fructose, C6H12O6, is a natural sugar in apple juice. A person with diabetes must be aware of the quantity of sugar he or she consumes. The amount of concentration of fructose in a certain brand of apple juice is 0.67 moles per liter. What mass of fructose is present in a 250 bottle of apple juice? 250 ml bottle of apple juice. Okay, so we are given in this question, our substance obviously is fructose, and we're given the C, amount concentration, and we want to know the mass. And we have the volume, 250 mils. So the concentration of C6H12O6 is equal to 0.67 moles per liter. And our volume is 250 milliliters, which is 0.250 liters. And we want to know the mass of our fructose. That's what we want to find. So we are going to use our formula, C equals N over V. That's what we have. So from our formula, we are going to find, that's right, N. That's what we're missing. So find N. So C equals N over V. N is equal to C times V, which is equal to 0.67 moles per liter multiplied by 0.250 liters. And this time we'll cancel out liters, which leaves us with moles. And how many digits will we need? Well, looking to our question, again, we have 2 digits. So through our question, we write down 3. But we keep everything in our calculator. So 0.267 times 0.250 is, so we need to put down 3, so 0.168. We'll round it, but we keep all the numbers anyway. 0.16, oops, I gotta make that an 8. 8 moles per liter. Oh, just mole, sorry, just mole. And now we are then going to, from there, find our mass. We have our moles. So again, we're gonna need our molar mass of our substance. So the molar mass of C6H12O6 is equal to, I'm gonna give it to you, you'd have to look it up, 180.18 grams per mole. And so we're finding our mass, C6H12O6. And that's equal to, we're gonna use N equals M over capital M. So little m is equal to N times capital M, which is equal to 0.168 moles times 180. Oh, I think you might not be able to see that. Slide it up, 180.18 grams per mole. Cancel out that, and we'll be left with grams. So put that, leaving my numbers in, times 180.18. So 30. So we're gonna keep that 30. So M is equal to 30 grams. So therefore, the mass of fructose present in a bottle of a 250 ml bottle of apple juice is 30 grams. Okay, so those are a couple examples, and there's some questions for you to work on page 402. I've shortened it up to just 1 to 7. So work through those. Please reach out if you have any questions. And that's the end of the lesson. Take care. Bye.